So the question is, kth largest element in an array. So we would be given an array, let's say 3, 2, 1, 5, 6, and 4, and we have to give the kth largest element. K would be also given to us. Let's say k is 2. So when we sort this array, if I sort that, it would become 1, 2, 3, 4, 5, and 6. So I want the second largest element. This is the first largest element and this is the second largest element. The question is asking us to return this second largest element. Okay. So one solution to do this is, first we would sort the array what is given to us, and we would traverse from the back side, and we will take the kth element. We would take a loop from the back side, and that kth element, if k is 3, we would traverse, this is 1, this is 2, and this is 3. At that situation, we would return kth from backside after sorting the array. So this is like a brute force solution. Now, the time complexity for this is, for sorting, we would take big O of n log n, and for searching from backside, we want to search k elements from backside, so that would be big O of k. Now let's see an optimal solution for the question. For an optimal solution, we would use a heap data structure. In that heap data structure, we would add all the elements that are present in my array. So what I will do, when I encounter my first element in the array, I would directly add in the heap. Then I go traverse to the next element, that is 2 over here. So I would go in my heap data structure, that is priority queue. I would add that element as well. Similarly, the entire array I would traverse, and then I would add all the elements present in the array. So 1, 5, 6, 4. Now we know heap data structure has a specific property. That is, if we take a max heap, it will arrange itself such a way that greatest element, that is the greatest element, it would come at the top. This is the greatest element. After we add, it would come at the top. So 6 would, this 6, it would come at top, and all the other elements would rearrange themselves. So here 4 will come here. So at first I have added the entire array into my heap, and the heap will contain the greatest element at the top itself. Now what I will do, they have told in me in the question that give me the second greatest element. Now I know if k was 1, then I would have returned the 6. Why? Because this is the first greatest element. What? It's now easy, no? So we want the second greatest element. So what we will do, we would remove the top element from the heap, the greatest element from the heap, and then you take the next greater element. If I remove one greater element from the heap will now rearrange itself, and it would give me the greater element that's present in the heap now. Okay. Now, so after removing 6, the next greater element present in the heap is 5. So now 5 would come at top, the next greater element. So I would remove it as well. So for k equals to 2, my 5 is the second greatest element. I think you have understood the solution. Now let's go for the implementation, and it's very easy to implement as well. Let's see it. This is the this is the C++ implementation. So I have written a priority queue over here. So this priority queue is max heap by default, and then for every int x in nums, that is my every element in my nums array, I would push into my heap, that is max heap, the answer heap. Okay, so now I would take int k max is equals to int min. So this is the variable that will store the kth largest element. Now for int I equals to 0, I less than k, I plus plus. I want the kth largest. So that time I would go on removing from the heap. So I would remove the first greatest, and then the answer dot pop I would remove from the heap as well. You may be knowing this. For the second iteration up till k, this will happen, and at last we would get our kth largest element. Now we would return this kth largest element. The time complexity for this would be here, it would take around big O of n, and for every time you are pushing in a heap, so it would take big O of log n as well to rearrange itself. So this would result us in big O of n log n, and here we are removing k times. Okay, we are removing k times from the heap, so this would also take k into log n. The removal from heap as well, it would also take k log n. So these, it will take around, the total time complexity would be big O of n log n. This would be the time complexity, and space complexity, the max the heap would store big O of n. Thank you. If you found this video helpful, please like and subscribe.